Hi, this is Dr. Hongdu. In this short video, I'm going to explain how multiplication rule works and how you can use it to solve probability problems. Hopefully, after watching this video, you can learn to solve similar problems by applying the same rule and logic. Here we go. A single die is rolled twice. We want to find the probability of rolling a 6 the first time and a 2 the second time. We're going to use two different methods to calculate this probability. One is the theoretical probability formula. The theoretical probability formula says the probability of an event can be calculated by dividing the number of all possible outcomes in the sample space from the number of outcomes in the event. So let's first think about the sample space of this random experiment. When the die is rolled the first time, there are 6 possible outcomes. So for each of these outcomes, it produces another 6 outcomes when the die is rolled the second time. So the total number of possible outcomes is then 6 times 6, which is 36. Now let's look at the event. Roll a 6 the first time and a 2 the second time. It is just one particular outcome. So the probability of rolling a 6 the first time and a 2 the second time is 1 over 36. Actually, the probability of any particular outcome is 1 out of 36. All of these 36 outcomes are equally likely since the die is fair. The second method I'm going to discuss is the multiplication rule. Multiplication rule says the probability of an event E and event F both occurred equals probability of E times the probability of F. Now let's apply that to our probability problem. Probability of rolling a 6 the first time and rolling a 2 the second time equals to the probability of rolling a 6 the first time, which is 1 out of 6, times the probability of rolling a 2 the second time, which is also 1 out of 6. The answer would be 1 out of 36. So this result is consistent with the answer we got using the theoretical probability formula. When we calculate the probability of rolling a 2 the second time, we're not taking into account the occurrence of a 6 is rolled the first time, simply because rolling a 6 the first time does not affect how we calculate the probability of rolling a 2 the second time. So in this case, we say these two events are independent. Simply speaking, when you calculate the probability of one event, if you don't have to take into account the occurrence of the other event, then they are independent. Now let's take a look at the formulation of multiplication rule. If event E and event F are independent, then probability of E and F both occurred is simply the product of probability of E and the probability of F. In the case event E and event F are dependent, the probability of E and F both occurred still equals probability of E times the probability of F. However, since the probability of F now depends on the occurrence of E, then we use the notation P, open parentheses, then a little vertical line, followed by the letter E. It is read as the probability of F given E. Now it's time to do a little practice on applying the multiplication rule. You can pause the video anytime if you would like to work out the answer before it is being revealed. Let's see the die is now rolled 3 times and we would like to find the probability of getting a 5 the first time and the 1 a second time and a 6 the third time. We also would like to find the probability of rolling a 6 3 times in a row. The answer to the first problem is 1 out of 216, which comes from the multiplication rule for independent events. The answer to the second probability is still 1 out of 216, according to the same rule. So although you might think rolling a 6 3 times in a row is less likely compared to other outcomes, they are actually equal. As a matter of fact, all outcomes are equally likely in this random